Hi, welcome back, power system engineers. Happy new month and happy Sunday. In today's video, we shall continue with our learning series on ETAP. Without further ado, let's try to open the existing file. You click on the example 20 if you are following the video, double click on OK, select project editor and master and editor, click on OK. Let's wait while it loads. Alright, we now have our design circuits. We have the grid, we have the 33 kV breaker, we have the bus, we have the power transformer, we have the cable, we have the breaker, we have the bus as well, 11 kV bus, cables, circuit breakers, and we have our lump loads. So let's dive in. Ordinarily, this is how the interface will look like by default. So if you hover on PQ by the top right, you see PQ, and one of the good things about ETAP is it will show you what exactly it stands for. So if you check it, you see load flow. Switch the current presentation to load flow analysis mode. So you click on PQ, then by the top right you see PQ. If you hover on the PQ, it will show what it actually stands for as well. Run load flow calculation. So you click on it and then give it a name. Okay, let's say load flow August. Load flow August. Click on OK, and okay. One of the good things about ETAP is if there is an error in your computation, like the arrangement of your circuit, or there is a parameter you need to set for a particular equipment, it will show you and then give you where exactly the problem is. Okay, it says error 706-01. So we have T1, which stands for transformer, and positive sequence X over R is equals to 0, which is not supposed to be. So you click on the circuits. Then let's go back to our power transformer. If you can recall, it says T1 transformer. So you double click on it, then go to impedance. The X over R is actually speaking to impedance. So it says this X over R cannot be 0. So one of the key feature of an ETAP is it has typical X over R and Z. So we might want to use the typical X over R and Z available on ETAP, since we did not have the information available with us. So you click on typical X over R and it will auto generate the X over R. So you click on OK. Okay, let's click on this typical value. Alright, click on OK. Then let's run the load flow again. Let's see what we have. Alright, the circuit is now running. As you can see, we have the power transformer. If you look at it now, you see that the power transformer is on red. The cable, 11 kV cable, is on red. The 11 kV bus is on red. This red colored part of the circuit means those components are overloaded. Why? If you look at this part, let's go to this power transformer. It means the secondary current of a power transformer is 786 amps. Alright, can you confirm that? Okay, so you can confirm it manually at your end. But the secondary rating of a power transformer, 15 MVA power transformer, 33 stroke 11 kV is 787, 787 amps. I mean, so at the secondary side. So, and if you cannot confirm that, if you sum up this um, transformer, now this loads, we have 4, we have 5. If you sum these together, we have 9. 9 plus 6, 6.6, which is 15.625 MVA. It means the total load on this transformer is greater than the rating of this power transformer. That's why the ETAP colored it such that you'll be able to know that these loads cannot at a time at a point in time work on this power transformer. To safeguard the life of your equipment, you have to carry out what we call load shedding by opening one of this breaker. Okay, but before we do that, I think we can actually work on the results, the output of this load flow. So you click on display option, it will give you different options like the results that you are getting. So currently we have the magnitude of the bus voltage in terms of magnitude, and then the type of voltage you are going to see is line to line voltage, and then the unit is in percentage. That's why you are seeing 93.41%, and you are seeing 100% at the 33 kV bus. So if you actually want to know the voltage on the bus in terms of kV or in terms of voltage, so you are going to select your desired output. If you want it in kV, you select kV. If you want it in voltage, you select voltage. But by default, ETAP will give you the bus voltage in percentage. So in my own case, I would like to use kV. So you click on apply and it will change. So we now have 33 kV voltage at the 33 kV bus. Can you see? If there's any voltage drop, we will actually know. The voltage will drop less than 33 kV. So let's go to the 11 kV bus. You can actually see that the 11 kV bus is 10.28. So against 11 kV that we are expecting. All right. So the load flow, the unit is in kVA. Then we have different type of different options. By default, ETAP will give you kilowatt plus the reactance. But in this case, for clarity, we are going to select kVA plus amps. All right. So you click on apply. So, and then you might want to know the voltage drop, probably on the cables or on the line. So you click on under voltage drop, you check the line or cable, then you click on apply. Then okay, let's click on, I think we need to put this bus voltage to voltage so that we'll be able to see the voltage drop at this level. So you click on apply, then click on OK. So it will give us the uh, it will give us everything we need to know about this load flow. So let's try to analyze all these um, parameters. So if you inject this load on this circuit, it means we have 16301 kV. All right. So this 16301 stands for the kVA. So if you try to convert it to MVA, you divide this by 1000 and it will give you the kVA, the VA rating in MVA, in MV, in megavolt ampere. So we have the current, and if you can recall, one of the profile we are going to get from carrying out load flow is the voltage, the current, the power factor, the var, and lots more, the voltage drop as well. So we have the kVA, 16301 kVA. If you want to get it in MVA, you divide this by 1000 and it will give you in MVA. So we have the current. At the 33 side of the power transformer, the current flowing at the primary side of the transformer is 285.2 amps. As you can see, we have 285.2 amps. What this means is if you multiply 285.2 by 33,000, let's see what we'll get. Alright,